Hello everybody and welcome to another episode of Future Engineering Bets. Today's very exciting episode looking at McMurtry technology with Iain Wight, who is the director of McMurtry Technology.
People have said for years that their car produces so much downforce they could drive it upside down. Nobody ever has until we did it last summer. I think that's really exciting.
Buses being so heavy that they leave dents in the ground where they stop and ripping up the tarmac. The EVs got too heavy in meeting the demands of the consumer with the infotainment, the tech, the range. It also defies all sense of sustainable and ethical thinking to think that a single person to get themselves from A to B could be driving a 3+ ton vehicle. The ethical view on it is this is an extremely inefficient vehicle.
When you look at batteries that are being used in motorsport, we now have a production option for a battery that has the same level of capability, if not better, than some of the motorsport applications in a production environment.
Hello everybody and welcome to another episode of Future Engineering Bets, where we talk about future innovation in advanced engineering and where capital investors and companies and CEOs will be thinking about investing their capital in the future. Today's very exciting episode looking at McMurtry Technology with Iain Wight, who is the director of McMurtry Technology.
Thank you.
And we're going to be discussing battery technology, downforce, high torque, lightweight motors, all sorts of very exciting things. And we've got a lot of interesting concepts to talk about with the future engineering or electrification and high performance sectors in particularly, which you're going to tell us all about your background in a moment, Iain. So without further ado, Iain, welcome to Future Engineering Bets.
Thank you. Thank you very much.
Thank you for joining us. Do you want to tell us a bit about yourself? You're a very interesting background.
Well, if I go back far enough, I started originally in electronics as an engineer, but nobody would ever trust me to engineer anything now. Started in aerospace, working on inertial navigation systems actually for Tornado and Harrier aircraft. And then for some reason wanting to work with cars, so moved into electronics, first of all with Bosch, then with a company called Pi Research actually, that we had the benefit of supplying pretty much every piece of electronics at one time pretty much into the pit lane at every level. So everything from Formula One right the way through and downwards to go-karting, which was just a fascinating introduction. I then moved completely into mechanical systems with gearboxes and ran the high-performance transmissions division of Ricardo for close on 14 years ultimately, actually. One of the programs that we worked on at that point was a transmission on the Jaguar CX-75. That brought me into contact with Williams. I moved to Williams Advanced Engineering as a director there in 2017, and we did some really interesting programs at that point up until the sale to Fortescue. Then went off and made lithium-ion cells in Europe, which for a while, which was reasonably challenging, but incredibly interesting and fascinating to do. In amongst that, I was also chairman of the Motorsport Industry Association for around about 6 years as well. And that's all brought me to McMurtry, actually, which is, I think, one of the most fascinating companies around just now from a technology point of view and a vehicle point of view.
I have to say, a very interesting career. I'm sure there's been a lot of challenges as well as enjoyment on that journey, and there's so much history in that different group of things. And so tell us, what is it that McMurtry do for the layman listener?
McMurtry has been in existence now, McMurtry Automotive, for 10 years. And it was set up by Sir David McMurtry, who felt that cars, especially high-performance cars, were becoming far too big at the time. And if you look at any high-performance cars, they are big. A lot of them are very heavy. He wanted a small, highly performant car in a tiny package. And he set a very small team up to do that on initially quite a small budget, actually. And the result of that was the McMurtry Spéirling, which pretty much one of its first public appearances came out and broke records that had been set by Formula One cars up the Goodwood Hill climb, and has then gone on to set further records. And now what's very exciting is that we are now heading into production with the car. Now, my side of the business at McMurtry Technology takes an awful lot of those clever packages from the car So things like the battery system, the electric drive unit, the downforce system, and applies it into other sectors and other areas.
It's fascinating, isn't it? And I think there's a few things in there. One is the breaking the records of Formula One cars. That in itself is a statement that has done huge amounts for your PR at McMurtry, but itself is such an achievement, you know, on racetracks, we say in Goodwood.
When I walk around the building here and I look at the pictures of the original Goodwood car, and it was a group of 20 or 25 people. And when you start to look at true innovation and how it comes about from people trying to solve problems. And in that, trying to solve the problem of making a car go faster than a Formula One car that's very small, doesn't have big aerodynamic surfaces. How else would you do it rather than suck it to the ground? Which is exactly what they did. I was working on a car, a hypercar for a large manufacturer at the time. And I thought that we had a pretty good understanding of what was happening in the world with hypercars. This very small group turned up at McMurtry and just turned up at Goodwood and just blew us all away completely. And it's phenomenal. So hence the appeal of me coming to help here and hopefully take some of that technology out into other areas.
And you've been developing the technology for the production car and you're into the early stages of pre-production now. What are the key application areas that McMurtry are looking that you feel at this point? Because we both know that engineering takes its own course and some of the future applications will be very different to the ones you're thinking right now. But where are the focus points for McMurtry?
We have quite a number of opportunities around us. There's a lot of battery manufacture now. There's a huge amount in China, as we know. But there's very few people that can actually produce a very high-performing battery in small space volume and lightweight. And when you look at the duty cycle of our car, it's very extreme. So we need to have a lightweight battery that generates a huge amount of power, stays safe, and runs relatively cool. So that when a person buys a car from us, they can take the car out on the track, they can recharge it, they can take it back out on the track, they can recharge it, and they can do it throughout the day in a high ambient temperature. Now, when you have that capability of making a battery like that, it's very easy then to take that core understanding and apply it into other areas. Now, they could be traction batteries for a high-performance vehicle. They could be a high-performance battery for a hybrid vehicle. It could be into aerospace. It could be into other applications, such as marine. It could even be into rail. Everybody is looking, or a lot of people are looking for high-performance options rather than a commodity-type price unit.
Very interesting. So you've got potentially wide-ranging sectors, not only the high-performance automotive sector, but it could roll into, like you say, aerospace.
It could defense, roll into other areas, exactly. Yeah.
Rail, marine, all of which are very large-scale, heavy engineering. Yes. Some of those are.
Yeah.
But the principles work in the same way.
Exactly.
Potentially scaled up on it.
So our production car, the battery in it is a 100 kilowatt hour pack. It can produce a peak power of well over 1.4 megawatts. We run an 800 kilowatt traction motor in it, and the car can go round the track for quite a significant period of time, producing that power and keeping cool and staying safe at the same time.
Which is quite the achievement.
Oh, and I should say all of that at well under 500 kilograms in mass.
Yeah, it's incredible, isn't it?
It's very good. When you look at batteries that are being used in motorsport, we now have a production option for a battery that has the same level of capability, if not better, than some of the motorsport applications in a production environment.
Which is exciting days, particularly when you talk about, and to the person watching this, they might be thinking that doesn't really make a lot of sense. If you just explain, maybe in terms of a power to weight ratio of what that McMurtry is producing versus its weight, you're into significant high performance territory.
Yes. Right? If you look at our Goodwood car, it's a good example of it. It is a car that weighs around about 1,000 kilograms. If you look at a performance car now, it's virtually impossible to find anything under 1.7 tons, 1.8 tons that has any level of electrification in it. There's still cars with combustion engines that are around about 1.4, 1.5 tons, but they're becoming few and far between. The original ethos of the company was to set up a car company to make small, lightweight, performant vehicles. And that's what we are continuing to stick to. The production car is a little bit heavier than that, but it's still absolutely class leading by any scale from a mass point of view.
Really interesting. And it takes us into one of the topics we're going to talk about, which is the weight of EVs having exploded. And, you know, the BMW M5, for example, has come out, 2.5 ton vehicle.
Yeah.
We know that no matter how good you make a car, and apparently I've not driven it myself, apparently it's fantastic, but there's limits to physical mechanical grip through a tyre at the end of the day, and active suspension can only do so much. And the true art of driving and the enjoyability of driving come from that agile. That's what motorsport is built on, lightweight, high speed thinking. And we talked earlier, and I mentioned even things like buses being so heavy that they leave dents in the ground where they stop and ripping up the tarmac. The EVs got too heavy in meeting the demands of the consumer with the infotainment, the tech, the range. Where will the push come from, I suppose, on the consumer side, with hitting the OEMs? But a lot of this technology you're looking at does have a route to enabling lighter weight applications with your high torque motors, lightweight motors, with the density work, with the thermal work. Did you want to explain a bit about what your thoughts are?
It's a really interesting point, because just now there's a lot of headline performance numbers on 1,000 horsepower, 1,500 horsepower, 2,000 horsepower. How much driving enjoyment you actually have from having that much power is very debatable, because there's very few areas that you can use it, and you can only use it for a small period of time as well in those areas. If you go back to pure driving enjoyment, you come back to the Colin Chapman ethos, all of the other aspects of reducing weight. Any mass that you have on the vehicle is dynamically handicapped, because you have to accelerate it, you have to brake it, you have to turn it. So therefore, cars are getting very heavy now. I can see performance cars coming back down and being actually enjoyable to drive again. Some of the big, heavy electric vehicles, they're brilliant. Don't get me wrong. They are superb pieces of engineering, but they are heavy and they are cumbersome, and you feel the weight. And you can control an element of that with electronics, with the systems on the vehicle. But ultimately, it's inefficient. You're carrying a lot of weight for not a lot of reason. The other aspect, actually, if you then take that into a luxury aspect and start to look at electrification for a luxury car with a high level of range, suddenly you're going outside of a normal passenger car, and you're actually getting into the mass of a light commercial vehicle. And I don't know about you, but I don't want to buy a luxury car, not that I can afford one, but a luxury car that is classed as a light commercial vehicle. And it is quite worrying that way.
It also defies all sense of sustainable and ethical thinking to think that a single person, to get themselves from A to B, could be driving a 3+ ton vehicle, which the Tesla truck would be one of those.
Yes.
Where just in order to hit the stats, the actual genuine sustainability the ethical view on it is this is an extremely inefficient vehicle causing damage to the roads and the highways that it's driving on. Is that really the purpose of electrification in the first place?
Shouldn't be. Electrification is incredibly efficient at taking energy and converting it into forward motion, for want of a better phrase, on a vehicle. It does it so much better than anything else. Better than hydrogen, than combustion engines. But the penalty of that is battery weight. Now, cell chemistry is developing at a huge amount. There's obviously there's 2 or 3 aspects within that. We utilize an NCA cell. Other people in high performance utilize NMC cells. Some people are using now to get the life cycle up in vehicles, so using lithium iron phosphate cells, which are great because the life cycle goes up hugely, but you've got quite a significant weight penalty, roughly about 30% weight penalty at that point. And that, some of these things are consumer driven. They want lower cost, which lithium iron phosphate does, and you want higher life cycle. So there's always a trade-off on that. From a high performance point of view, the cell chemistries are increasing in power and energy density, probably around about 10, 12, 13% a year. So as a result of that, you can have a smaller battery or you can have more power. A lot of the move just now has been towards bigger batteries. Most people don't really need a bigger battery if they use the charging infrastructure effectively. If they use the charging infrastructure, you only want to drive for a couple of hours at a time anyway. Fast charging at that point, you can turn the car around quite effectively in 10 or 15 minutes. And it becomes pretty efficient at that point. By the time you've visited the services, you've had a coffee and you're back out again. It's a slightly different mindset rather than thinking purely about range.
And that takes us into battery technology and its lifespan. And one of the things that stops people buying electric vehicles currently is the fear of the life of the battery. There's a lot of negative press about the degradation of the cells, and particularly when you're out of warranty. People fear they're buying a time bomb because the cost of the battery, particularly on platforms where the car is integrated onto a chassis where the battery's buried inside and the serviceability hasn't really been a consideration. The people are scared. They're scared of buying second-hand cars. Now, as an engineer with the knowledge you have, you're not worried about buying a second-hand electric vehicle. But for a lot of people, that the drive to fast charging also then drives the reputation that there's damages and forces degradation to be faster. Which leads people to then carry on their fear and worry of, well, how do I get into that space? So the technologies that are coming out in terms of thermal management, what you're doing in terms of the cell densities, how is that going to feed ideas in the future? Because this high performance is the key. It not only gives you high performance, but it can help with battery life as well, if used in the right way.
You have to manage your battery pack effectively so you do not damage the battery by fast charging. That's a given. Fast charging will reduce the life of a battery, so you should limit your fast charging to a certain extent, whatever happens. Now, we as a high-performance electric car manufacturer, our opportunity for doing that is that we've made sure that we work with a cell supplier that has a complete upgrade route. So just now in our production vehicle, we have a 5 ampere hour cell. We will upgrade that battery pack in the future for customers to a 6 ampere hour cell, to a 7 ampere hour cell. That will increase the energy density in the battery from 100 to 120 to 130 kilowatt hours and be a direct route for them to keep on enjoying the performance of that over time. Now, it's slightly different if you're buying a car because the battery will degrade over the time. But batteries are not degrading anywhere near as fast as expected. I have a what I'd term a disposable car electric car that I bought for a very low price. The range isn't great on it, but from an efficiency point of view of driving from A to B on a commute, it's absolutely phenomenal. But if I want to have fun at the weekend, I'll have something that revs quite high and has combustion. And that's one of the things that has always appealed to me with the McMurtry Spéirling, is that when people look at the car, they don't automatically think of it as an electric vehicle. They just think of it as a high-performance vehicle. For one thing, it makes noise. It makes noise from the fan and downforce system on the car. And that's actually quite exciting. If you watch the car launch, it is genuinely exciting. If you watch a Tesla or an EV launch, they're very efficient and they're very fast, but it's not that exciting, is it?
It's not.
You just have to go to Goodwood and watch the electric cars going up there and see how people then go off and do something compared to a V10 Formula One car. Watch our car going up the hill and it's quite different. Its performance, its noise, its atmosphere, all these things are very important, I think, for vehicles. But when I'm commuting, I want the quietest thing possible. And that does come from electric, I'm afraid.
Interesting. So for a lot of people, they're always trying to combine their one car into everything. And that's the reality for a lot of people. They have the opportunity to buy only one car. Yeah. And I suppose that's where the manufacturers, such as the Hyundai Ioniq 5N, where the simulated gear changes, DCT box in there. And
have you driven one of them?
I've personally not. No, it is on my list to drive.
You need to have a drive of them. We at McMurtry think that type of aspect is really important. So much so we actually bought one and we use it at the track for sighting laps. And it is good fun to drive. You do notice the weight of the car though within it, but it is great fun to drive. But it does go through my head that it is false, that noise going through it. And I do like a mechanical noise, if that makes sense.
Yes, absolutely. It's the same with simulated through the speakers when you drive a car, and it sounds synthetic, doesn't it? You can't get away from the synthetic sound in them. And so as you look at then getting into, let's talk about the high performance sector specifically. So there's a real opportunity in the high performance by managing the power density, by the quick discharge, the quick charge. It plays itself into that environment. I hear it's great that people can also look at an upgrade path with you in the future with their investment with McMurtry. Where are people's fears when you hear them? What challenges are you facing?
There's a lot of negativity on the internet. Some of the stupidity that's been put on there, like tire particulates and other aspects that have been done. You don't really get through tires any faster or slower on an EV than you do in a combustion car. So there's a lot of misinformation on the internet. What I see is that if you have an amount of energy, now if you take hydrogen, I know that you've worked with hydrogen a lot in the past. I would love for hydrogen to be prevalent because it allows you to have a combustion engine making noise, utilizing all of the infrastructure that we have already for manufacturing combustion engines. But the transition of taking your energy into hydrogen, you lose, 70–80% of that energy in the conversion process. Hydrogen's pretty tricky because it's quite small. It escapes and corrodes pretty quickly. So there's big challenges in getting to that point. The best that you get on efficiency on a combustion engine is generally, in Formula One now, it's absolutely brilliant. They're achieving over 50% efficiency, but that's still only 50%. On an EV, you run 97–98%. If you take your renewable energy, feed it straight into a car, it's pretty much directly translated to the rear wheel. And it's difficult to get away from. I sound like I'm becoming a bit of an EV person. I am a genuine petrol head, but you have to look at the efficiencies and how you utilize that car.
I mean, a lot of people are arguing at the moment, and when you look at the sustainable fuels, be it e-fuels, synthetic fuels, and other things, that the closed loop CO2 argument, which is to say, as long as you're not putting out more than you're taking in to produce the fuel, it doesn't matter. And that seems to be leaning into the high performance car companies that have had to stop some of their EV plans because the demand just simply isn't there. And they're moving back towards V8 hybrids, where they'll be putting in, they could be putting in some of your technology in the future to help with that.
The legislation for electrification was very prescriptive when it was brought out. I would have personally liked it to have been a little bit open to allow a level of innovation to still be achieved with combustion technology. I think the world would be a better place for having a mix of energy storage solutions in the future within vehicle. We went electric because you'd be pretty brave in 2016 to start a car company that was anything but electric. But also the way that we run our systems on the car, it's essential that we have an electric energy store to run the fan downforce system. And then when we talk about efficiency on that, if you look at a conventional hypercar and how they generate downforce through wings. Now, wings induce a huge amount of drag. There's a really good article on the internet, actually, from the person from Engineering Explained, and he talks you through how we took the McMurtry Spéirling and we drove it upside down using the downforce system. But one of the things that came out of that, he looked at the efficiency of the downforce system, and we generate, for every kilogram of downforce we generate, takes about 30 watts of power. A conventional wing uses about 180 watts of power. So our downforce system is 6 times approximately more efficient than a conventional wing. So therefore, the downforce system that we have works very well in electric. Because if you look at Formula E racing, it's very much about it's very much an energy format rather than a power format. You only have to watch a few races to understand the energy conservation right the way through the race until the last few laps. And all of the first 25 minutes or so is generally around positioning. Now, I like performance. I like people to go racing and go properly racing and use the power that's available right from the word go. And that's what we've built into our car, so the power is usable, really.
Yeah, it's a really interesting area, particularly when you're looking at the conservation piece. And it makes me wonder whether or not Formula E or another format in the future could be one of the first to trial this different type of active aero and active using the fans to suck the car to the track, reducing the amount of wing on the car.
It's a very efficient way to do it. And Formula E has been phenomenal in what it's done, what it's achieved, and how it's captured a whole different fan base in a lot of ways to Formula One. I've been directly involved with it in the past. It's a great form of racing. The format is great. The sporting regulations are good. I would love to see it developing into future areas of technology, such as force downforce system, because they make sense for that type of racing.
And force downforce does have it. We talked earlier, force downforce, you mentioned that it could be used in braking applications in passenger cars. Could it be used to help reduce the need for, all the modern cars are kind of looking the same. You take a modern SUV, they all have the same teardrop sort of design, and it's looking like a bit bland in terms of every Chinese SUV starting to look like every other SUV. And that story, does force downforce open up design so that you could say, well, actually we can eliminate some of the drag in other ways and we can be a bit more bold in our design?
It does completely open up the design of the car. I will counter that in the fact that it opens up to having a very efficient low CDA on the car as well, low frontal area if you wanted. But you've got to balance that with your pedestrian protection regulations and within your homologation. But it does create a lot more flexibility in how a designer would design the car, because he does not have to have front, rear wings, any other aspect from the original design.
And the streets would all be cleaner, right? Because you'd be hoovering up the dirt off the roads as you drive around.
Probably wouldn't want to run one all the time on the streets, because it would need the collector boxes emptied a little bit on that. And you might be a bit of a challenge with some of the road furniture. But if you had a car that you wanted to initiate a track mode in, and have something that you could pretty much drive around the outside of any conventional car, then that is the way to do it. You go to the track, you put the track mode on. You could then tie that in with the safety systems on the car, so that if you're on a motorway on a cold day, for example, and there's a pile up in poor condition ahead of you. Now, the safety systems on vehicles are brilliant now. The radar systems are great. But you still have the laws of physics. You still have summer tyres, often in the UK, on cold, wet roads, and the mew for braking is pretty awful. You hit that brake pedal, you lock up, and you slide a long way when you're travelling at motorway speeds. If you had a downforce system that could be deployed quickly, and we can spin up our fan system incredibly quickly, we could, I don't know what factor of downforce we could have, but you could stop it a lot quicker in an emergency situation. And I would love to see that coming into some cars in the future.
It's an interesting concept area, even deployed on a small scale, which I imagine it would be to begin with. See where that goes. Very interesting.
I won't go into the specifics of our car, but there's been quite a lot of analysis done on the internet around it. And I think it's pretty clear that we generate around about 2 tons of downforce on our car. Now, 2 tons is a huge amount of downforce, but you could actually generate a very meaningful amount of downforce from a lot smaller area that would be quite easy to engineer into a car, especially as electrification has freed up a lot of the areas within the car structure as well.
Well, it opens up the design flow that you can completely lay out the car however you want to.
That's exactly it, yeah. Bring in some of the I would say, the very high performance in-wheel motors that are coming out now, and you've freed up an awful lot of area on the car.
An awful lot of the car design that's ongoing is still to suit people's perception of what a car should look like based on previous generations of cars.
That is very true, yeah. Yeah. And having been involved in electrification of combustion platform vehicles, it's challenging. And you really have to start with a clean sheet of paper.
Mm. So moving on to technology readiness levels.
Yep.
And for the general viewer, that the maturity of the technology and the manufacturability
Yep.
of the technologies as they go forward, which is two different paths, but they intertwine. A lot of this is going to be early stage
Yep.
technology readiness levels. So that's innovative.
Yep.
It's being proven on a small scale.
Yeah.
And one of the challenges for McMurtry and other companies that are similarly innovative is how do we take that forwards into higher technologies? And we talked before about the pace at which the Chinese market's moving versus the Western OEMs that are moving around about half the pace generically to them. What's McMurtry's view on advancing technology that you're bringing into wider, higher volume applications?
We've been very careful on our battery development to take steps that we are, it sounds stupid, but capable of moving at the pace we have to move at. And we're on our 4th generation of battery now in the production car. We've learned a huge amount throughout that, from when the company started back in 2016 to where we are now. That's given us a capability to run a very high performance unit that's very safe, with thermal propagation at an absolute minimum that we are all comfortable with. We've spent an awful lot of time setting things on fire in this area to understand how you manage, how you develop, and then how you manufacture. Okay, we're not at scale, we're in a small volume, but we are still manufacturing at a scale in a repeatable way. That's absolutely critical for us. So you mentioned the Chinese market. What they have achieved in the last 20 years on electrification and manufacturing is utterly phenomenal. It's really given the European car companies quite a wake-up call. Now, I wouldn't even think about competing directly with them, hence why we are continuing to develop in the high performance area, because that's what we're good at. You just have to look at motorsport on a worldwide basis to look at where all the Formula One teams. We're pretty good in this country at actually developing high performance stuff. And for me, it's the stuff that gets me out of bed in the morning as well. So that's where we'll stay. We'll develop that very efficiently and very well, and we'll continue to have fun doing it.
That's interesting. From a McMurtry point of view, yeah, I get it. It makes total sense. The high performance aspects is where you can keep pushing and pushing and pushing without worrying about the volume and the scale and the tight margins and that other area.
We must be cost effective. We must be efficient. That's a given, because we're selling a car to a customer. That car must represent value to the customer. And I think that from a value per pound, well, there's not really anything better, really, is there? We can outperform cars that are multiple factors of cost higher than ours.
It's a good argument. I can't argue with that one. On a pound per pound and power
pound per
output basis.
performance.
Absolutely.
Yeah. Not even power output. It's back to because there's enough 2,000 horsepower cars around. It's pound per performance. And I'd hope that enjoyment comes into that as well, and usability.
Indeed. So as we get into the later parts of this episode, one of the things I was going to mention was there's still the FEV or the hybrid, depending on the setup of the car, applications. Do you see your technology being useful to help OEMs develop both EV and hybrids, with hybrids being, you're talking smaller motors, you're talking thermally managed high discharge events that could well suit a hybrid application?
A lot of people don't like hybrid applications because then you have the additional mass of a combustion engine and an electric system. I actually quite like hybrid systems, especially when you utilize them effectively to complement the combustion engine. And that's been done since the Prius came out, really, and before that, actually. And I like them in high performance applications as well, where you are using the hybrid motor to torque fill, where you're utilizing, you're taking some of the energy that you would have lost in heat through the brakes, and you're putting back into the tractive effort from the vehicle itself. So I do like hybrid vehicles that way. They present different challenges because you have much higher life cycle, you have higher charge and discharge rates. But again, it's down to the chemistry of the cells, the engineering and the management of the battery pack, and then how you deploy all of that and integrate it into the vehicle itself. So it's all good engineering challenges, and we've worked on a few hybrid systems now.
I know in terms of everyday cars, the future for people to think that they can still have that long range aspects if they choose to and not all countries have the infrastructure going in place. So the hybrid makes more sense for many countries in the world in terms of automotive.
It does.
You start moving into heavy trucking, rail, marine.
Yep.
It starts to really play to a strength of, I remember when we used to do it with the hydrogen fuel cell vehicles, was very much setting up the platform to be a load balance platform, which is you manage your main load with the primary engine, and you really use your electrification to manage peak loads and acceleration demands and things like that, rather than seeing it as even a total combined. You're going to use it that way all the time. Most people aren't punishing it. So there's that aspect, but I do like the aspect, and you're seeing it with the car companies already. The Lotuses, they're all scrabbling back to the hybrid, the V8, the V8 drawing board, and saying, right, how do we give people the high revving feeling, the noise, but equally the instant torque? Because one of the best things about owning a hybrid, and I've had one for 10 years, is the instant torque followed by the backup of the engine. You feel like you've got the best of both worlds. I remember the first time I drove a hybrid, and I thought it's like driving a 4-litre car, and it's a 2-litre turbo with a battery pack, and then clearly you get that kind of power out of an EV, but you sort of feel like it's an in-between. And one of the things that maybe people are frustrated about in the engineering communities is the regulations went very much one way, 100% electric. Certainly in the UK, EU's got different regulations and they push a different direction, and they're also opening up theirs currently. But it doesn't solve everyone's problem saying everyone needs to go 100% electric.
No, and I wish the regulations weren't quite so prescriptive, because I think that engineering can continue to flourish in all of these areas for the future. And I think then you end up with the right solution for the right application at the time. It's interesting what you say about, you touched on rail, marine. I think a really good application of that is in the mining industry just now. And that's an area you wouldn't even normally have thought about for electrification. But if you look at what one of the big Australian companies are doing, they can generate an awful lot of their own electricity themselves in the desert from renewables. They can then take that energy straight into their haul trucks, their dozers, or other aspects, and they're not having to cart diesel fuel halfway around, around their country to do that. Now that makes economic sense for them, and there's no reason why it can't make economic sense into other areas. One of the big challenges with rail is the electrification of a lot of the lines for the future and the gaps within them. Battery carriage cars can help bridge those gaps between the overhead electric lines and the next station where they pick up again. So there's a lot of advantages in those areas. Plus then you pick up the regeneration on the huge braking distances that they have and the energy generation backwards again. So again, it's down to energy conservation and using it wisely and effectively. Which
regardless of whether it's fully electric or hybrid, plays itself into that arena very well. Well, Iain, thank you so much for taking the time to talk with me. Tell people where they can find out more about McMurtry.
McMurtry.com. One of my favourites, if Google upside down car, and you'll see the first car in the world to ever drive from rest upside down. And I think that's brilliant. Look at the Top Gear lap record things on Google, and look at the Goodwood Hill Climb lap record as well. But McMurtry.com will get you back to us. Thank you.
No, thank you. And we've not really gone into the car side of things today. Obviously, the car's really exciting. And I really would recommend having a look at that video, the upside down car, because it's mind boggling, because you're literally looking at a car, stationary, upside down, sucking itself effectively to the ceiling. That's the level of downforce you're generating.
People have said for years that their car produces so much downforce they could drive it upside down. Nobody ever has until we did it last summer.
What
I think that's really exciting.
what a record to break. I really think that is a fantastic piece of engineering, which is what I do get the sense, and thank you for showing us around McMurtry, the sense of innovation and genuine.
Thank you.
I call it old school engineering in the sense of it's innovative and it's not all process driven engineering. It's about people being creative.
People being creative, making things that they enjoy doing, and actually having quite a lot of fun in the process as well.
Fantastic. Well, thank you so much for joining us. Thank you for listening to this episode of Future Engineering Bets, where we look at the future innovation in advanced engineering and where people will be investing their capital. I hope you found it interesting today listening to Iain and the fascinating story of McMurtry. Please do share, please do like, send this to somebody and follow, and I look forward to seeing you on the next episode.
Thank you.
Thank you, Iain.